Second?
Our last days of class next week.
Okay. Yeah, let me, yeah, we are recording now, so let's go into that. Technically, as far as I can tell, and it's been a while since I looked at it, but the last day of class period is Monday. Since we're a Tuesday-Thursday class, our last day is Thursday. However, finals are Tuesday, Wednesday, and Thursday of next week, but I'll be giving you your final on the last test on Thursday, and you can turn it in anytime next week that you want to. I'll be here Monday, I'll be here Tuesday, Wednesday, and Thursday. So, and I'll give you, in fact, let me go and give you my schedule now. Monday, of course, I'm in class 8 to 10:40 and 11 to 1:40. Okay, that's Monday is the last day of class, so I'll be in class those. So anytime after 2 o'clock, should be in or around my office, so you can bring anything by then. Does everybody know where my office is? 265. 265. Yeah, let me show you on the little map here. Here we are in this corner room right here. Okay, you go out the door here, down the half flight of stairs, and then go almost to the end of the hall. Okay, don't go quite to the end where the stairwell is, but this office right before the stairwell, between the mechanical room and the storeroom and the stairwell, that's my office right there, 265. It's across from what's called the orientation classroom, which is what's called your desk. Right across from the 256. The numbering in this building is a bit strange, but lots of things about this building are a bit strange. I'm pretty sure I hit the button, but nothing happened. Okay. So I should be there most of the time Monday between 2 and 6. Tuesday, I have, since we have no classes, I'll be in the office primarily from 8 in the morning until around noon. Okay? At noon, I've got a final in this room, and it'll be probably approximately noon to 2. It may not take that long, but I'll allow myself, noon to 2. Then after 2, I go back to the office, and I'll be in the office until close to 3:30. 3:30, I've got to leave and go to the Birmingham East Campus, and if that's more convenient for you, I will be there from 4 to 6 on Tuesday and Thursday afternoon. There are no classes on Tuesday and Thursday, but I'll be there to take in the finals for the class that normally meets there. So I'll be there from 4 to 6 on Tuesday and Thursday afternoons. All right, that's Tuesday. Wednesday, I'll be here from 7:45 in the morning until probably 6 o'clock in the evening. All day long. I have no classes, just students bringing finals in. I'll be grading papers like crazy. So anytime Wednesday would be good too. Thursday, same thing. I'll be here from 7:45 in the morning until 3:30 in the afternoon. And at 3:30, I'll leave to go to the Birmingham campus, Birmingham East Campus. And if you are looking for me there, it's the Birmingham East Campus. It's the Ethel Hall Health Science Building, or Health Profession Building, I think it's called. And that's, I'm in room 103, very close to where you come in. Just there's a hall that goes either way. Take this one, go right past the restrooms, first classroom on the left once you pass the restrooms. So that's where I'll be Tuesday and Thursday afternoon from 4 to 6. Now, I can't recall for certain what they're doing about, now not this Friday. This Friday is still July. The college is closed Friday, this Friday. Next Friday is the first Friday in August. And technically we're closed, we're 4-day work weeks, June and July, okay? Well, August, are we working that first Friday or not? I thought I heard someone say we wouldn't be working that Friday, and then because it's in August, I'm not sure. But let me tell you this, whether we're working or not, whether the college is open or not, I have a treatment that Friday. I've got to be at the labs by 7, treatment begins at 8. I'll be there all day. So there's no way I'll be on campus at all on Friday if the campus is open, and I'm not even sure it will be. But I was going to say, if the campus is open, you can slide something under my door on Friday. First thing when I get in Monday morning, I'll be able to grade it, okay? I'd rather not have everything, because grades are due Monday noon, and I have to have everything in by Monday noon. So I don't want a pile of papers slid under my door Friday. I don't think that would happen, but and the same thing about Thursday. If this is the more convenient campus for you, and you don't want to go to the Birmingham East Campus, you can slide it under my door anytime Thursday, after 3:30 when I leave. You can do that too, and I'll pick it up Monday morning. All right, any questions? Does that pretty much close things? So, and the other thing is, I wish more people were here to hear it. I need everything in by Thursday, because I'm going to return all your tests, test 1 and test 2. I can't return research papers, number 1, because I don't have them yet, but number 2, because they periodically ask for samples of student writing, which just reminded me that's something I forgot to do for the documentation. But, if they miss it, I can add it later. Okay, still thinking that that planning hearing. So I will, that will be, I can't return research papers. I do want to return your first and second test then, okay? And I'll be grading like crazy trying to get those ready by Thursday. All right, any questions? Anything we've done so far? Scheduling, how we're going to operate, that kind of stuff. All right, if not, we started, we're in chapter 4, which is higher order differential equations. 4.4 is undetermined coefficients, the superposition approach. And we were talking about various functions that G can be. Remember, you have your differential equation on this side, on the left side of the equation. And if it's 0 on the right, it's a homogeneous differential equation. If there's some function of x on the right, can't be a function of y, that would have to be over here on the left. Everything dealing with y is on the left. Now there's stuff with x in it too, like your coefficients or whatever. This chapter they're all constants, but that could have some x's over here, but you can't have any y's over there. If you do, move them to this side with the rest of the y's. Okay, so your g of x on that side for your non-homogeneous form, we were talking about the various forms that can take on. It can be a constant, or it can be 0. It can be a constant, it can be a polynomial function, it can be a exponential function, can't be a log function, can be an exponential function. It can be a sine or a cosine, can't be a tangent or a cotangent or secant or cosecant, just sines and cosines. And it can be any combination of those. Sums, differences, products, wondering about quotients. In some senses quotients, but not maybe every sense of quotient, okay? But g of x can be any linear combination of the type, and here is the generic way to express this. These are your g of x's, but they're going to use the p of x, which we've used in other contexts. But remember, this is your g of x now, okay? The capital P of x, in this case, stands for polynomial function, which it did back in pre-calculus and earlier. A x to the n plus a sub n x to the n plus, it's a plus, a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus dot 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 plus a3 x cubed plus a2x squared plus a1x plus a0. Okay? That is a polynomial function. Any polynomial function can be your g of x, and any combination of polynomial functions and others, okay? Now, that's your polynomial. You can also have that same or some similar polynomial function multiplied by e to the alpha x, okay? So, you can have a pure polynomial function, or you can have a polynomial function multiplied by an exponential function. Now, alpha can be positive or negative. It can be fractions or decimals. It can be rational or irrational. It can be any real number in the world, okay? Now, there's another possibility. It can be that polynomial function or some other polynomial function multiplied by a sign, and we'll put beta x, okay? Well, they didn't put parentheses, so I guess I'll take them out too. Doesn't matter, I prefer it. It seems like it's easier. So a polynomial times a sign, or a polynomial times a cosine. And they use beta x there too. Not that it matters, but. Now, so G can be any linear combination of any of these, okay? A pure polynomial, a polynomial times an exponential, a polynomial times a sine, or a polynomial times a cosine, and linear combinations of this. A times this, plus B times a different polynomial of this, plus C times a different polynomial of this, plus D times a different polynomial of that. Just, I mean, they're not endless for the combinations, but it can be just about anything, okay? They usually won't be that complicated, but they can be, okay? Now, in here, because it's a polynomial function, can't be a negative integer. Has to be a non-negative integer, okay? This can't be a negative 7, okay? Or any of those can't be a negative 7, because that won't be a polynomial. You'll have the variable in the denominator. Rational type expression, those are not included here, okay? For polynomials anyway, okay? The ace of the n can't be 0, otherwise that would be an nth degree polynomial. You wouldn't have that term, you'd start with the other. Now, this can be negative, meaning you can't, that's why I didn't want to say you can't have rational form, not a polynomial, but you can with exponential. Exponential could be in the denominator, okay? So that's the only reason I didn't want to say the variable can't be in the denominator. It can't in the polynomial, but anywhere else it can. Okay. Now, I'm not saying a differential equation can't have other functions, but the approach we're talking about now won't work with other functions. For instance, it will not work for this. If g of x, that's the right-hand side, is equal to log x, not going to work. Not the thing we're going to be talking about. It will not work for g of x equal 1 over x, or any rational function where the denominator is a polynomial in x. It will not work for g of x equal tan x, as I said before, or any of the other trig functions other than sines and cosine. And it will not work for g of x equal for inverse sine or cosine of x. So inverse functions for trig functions will not work, okay? The inverse of a log is an exponential. That would work there, but the inverse of an exponential is a log. That wouldn't work. So I don't want to say no inverse functions, okay? So the set of functions consists of constants, polynomials, exponentials, sines, cosines, has a remarkable property that the derivatives of their sums and products are again sums and products of constants, polynomials, exponentials, e to the a alpha x, sines, cosines, okay? And because you can have linear combinations of any of these particular functions, you have all that to deal with. Now, point something out to you. One reason this won't work, log x. What is its derivative? 1 over x. Well, 1 over x won't work, okay? So you see a couple reasons. What's the derivative of this? Negative 1 over x squared. That won't work, okay? So what's the derivative of this? Sine over cosine. So here you, well, no, I'm sorry, that's what tangent is, and its derivative is secant squared. Won't work for secant or secant squared. And inverse sine, the derivative of that is a, mess with things in the denominator, radicals in the denominator. Won't work. Can't do it. And the other thing, notice that they don't have here, I'm surprised they don't list it, you can't have radical functions, okay? They won't work either. All right. Taylor? Okay. Let me just quickly go over the things I said earlier. In fact, I think I'll wait till the end of class, so before anyone leaves, remind me, go over the end of the term activities again. I did them for the folks who are here, but since more people, I know Jasmine's coming in, we will have things to do. So, there is a little statement here, I don't want to leave this one out. Because the linear combinations of derivatives of all these particular functions must be identical to g of x, it seems reasonable to assume that your particular solution, y sub p, has the same form of g of x. Okay, so that's something to keep in mind. Rod is here. Okay? And remind me before anyone leaves today, go over how we're going to wrap up the term. Okay. All right. So I think we're ready for example 1. Any questions before I move on? Okay. It says solve this. Y double prime plus 4y prime minus 2y is equal to 2x squared minus 3x plus 6. Okay. Now, we haven't done one like this. This is a linear second order differential equation. Here's the key. All the coefficients are constants of the differential equation part, the left-hand side. We haven't done anything with anything on the right-hand side except 0. So how would we begin this? Any clues? Okay, yeah, we're not going to mess with this yet. If you're talking about quadratic here, yeah, okay, that's good. We're going to go back to the homogeneous case. We're going to start with setting that equal to 0, okay? And let's solve this first. Y double prime plus 4y prime, I can't write, minus 2y is equal to 0. And what do you mean by quadratic? I'm sorry? Oh, okay, yeah. Okay. You're moving right in the right direction, but let me say this. Here's our assumption. Let y equal e to the mx. That's always what we do with higher order, linear, ordinary differential equations with constant coefficients. That's our assumption, okay? Now, the next step is write what we call I always forget the word. It's not associative equation, it's what's the word? Auxiliary equation. The auxiliary equation. And that is this. If you plug those in, what y is, what y prime is, what y double prime is, you get the quadratic equation. How does it read? Okay, the equation. M squared plus 4m minus 2. And set that equal to 0. That's the auxiliary equation from this m right here. Plug it in and see. That's exactly what you get. Now, to solve this equation, let's get where Curry's been wanting to go. M is equal to minus 4 plus or minus the square root of 16 plus, second, 8 over 2, which would be minus 4 plus or minus the square root of 24 over 2, which is minus 4 plus or minus, what can you pull out of 24? Perfect square. Okay, 24 is 4 times 6, 4 is a perfect square. The square root of that is 2, and you're left with the square root of 6, right? Okay, over 2. Well, 2 will go into this, minus 2 times 2 will go into that 1 time. So your answer is minus 2 plus or minus root 6. Okay? Now, what do we do with that? We plug that back in here. So your and they have a name for this one too. I want to say characteristic equation. Is that what it is? All these names they put on them. We did the complementary. No, okay. Okay. This, by the way, is called the complementary function. This is y sub c, and so I should be putting y sub c. This is the complementary function here. Okay, so I guess that's what I was looking for. The complementary function would then be some constant, c1, e to the minus 2 plus square root of 6 x plus some other c2, e to the minus 2 minus the square root of 6 x. Those are your two m's there, okay? So that's your complementary solution. That's going to be part of your total solution, your general solution. But what we have to do now is figure out a particular solution to the right-hand side. We got the easy part done. So the particular solution, y sub p, now remember that little statement they did at the right before the example. It seems reasonable to assume that y sub p has the same form of g sub x. Well, here's your g of x, so let's assume yp is some a x squared plus b x plus c. Not a bad assumption, right? Whatever we have needs to be generally of that form, okay? So what might we want to do? If that is our particular solution, we need to make sure that particular solution satisfies this differential equation, right? So what are we going to have to do? Because we're going to need it right here. Find out what yp prime is, the first derivative of y of p. And what would that be? This is y of p. A, second, 2a x plus b. And then what else do we need to know? Double prime, yp double prime. And that's going to be 2a. All right, let's make that a capital A, okay? Now, let's put that together. The y double prime is going to be 2a. Okay, here's Jasmine. All right. Okay. come in, Lauren may still come in. If not, they'll have to listen. Okay, so we're plugging in our particular solution as derivatives into that because that is supposed to equal that, right? So let's see if it does. 2a, that's y double prime, plus 4 times, what's your y prime? 2ax plus b, minus 2 times, what's your yp? ax squared plus bx plus c, okay? And supposedly that's supposed to equal 2x squared minus 3x plus 6, okay? We want a particular solution that will equal that. Well, let's see what we've got. I think I'm going to move to the top because I get into this mess when I start trying to write down here. So let's move up here, and that'll be 2a plus, distribute, 8ax plus 4b minus 2ax squared plus bx plus c, and supposedly that's equal to 2x squared minus 3x plus 6. Okay, we don't know that it is. Let's see if it is. All right. Now, easiest place to start, the x squared terms. If these are indeed equal, then negative 2a must equal 2, right?
I think you messed up on the top and obviously multiply the -2 by bx and c.
Okay. Oh, sorry. It's minus 2y, and I left off those. Yeah, you're right. Getting a little bit carried away here. Okay. Right. Thank you. So negative 2a is equal to 2. What does that mean? A has to equal. Not that hard. Negative 1. Okay. Now let's go to the x terms. Here's an x term. There's an x term. So this says that 8a minus b times x is equal to minus 3. So let's leave off the x's there, just deal with that. But we already know what a is. That'd be minus 8 minus b is equal to minus 3. How do we determine what b is? First thing, to make things a lot easier, I'm just going to multiply by minus 1, okay? I don't really care for negatives that much. So now I'll subtract, so I wind up with another negative, 8 from both sides. And that gives us b is equal to negative 5. All right? Well, one more thing. Let's see what we get there. The constant terms. 2a, and I'm going to come down here, but a is negative 1, so it'll be a negative 2, okay, plus 4b, but b is negative 5, so that would be a negative 20, minus c is supposed to equal 6, right? There it is, yeah, that's right. All right, so if we, add those two together, you get negative 22, add that to both sides, and you get plus 22 here as you wipe those out. So this will be minus c is equal to 28. So c is equal to negative 28. That's rather strange, but true. So what's your particular solution? I'm running out of room. Okay, so let me erase some stuff here. Don't think we need that anymore. Hopefully we did it right. I sure hope so. Let me make sure. Let me just look. YC is C1. They pulled out a minus sign on one of those and left it in on the other, so yeah, we got that right. So we don't need this anymore. We do need our characteristic or complementary solution. That's what they call that, complementary solution. Yeah, complementary function, okay? Now, I don't want to erase my constants because I need those. I just don't need this anymore. I don't need all that. I can do away with this. Because all I need is the B. Okay, I think that'll give me enough room. All right, now that we have our particular solution, yep, okay. Things are not looking all that great, but let's see. Let me write down the particular solution then. Y sub P is then equal to minus x squared minus 5x minus 28. Okay. I must have done something wrong, okay? Because they get a different B and C. The minus 1 is right. Where did I follow up the other?
It's supposed to be negative 2bx.
Yeah, it's a negative 2b, isn't it? I forgot to multiply the 2. Is that what you were saying?
Yeah.
Okay. Well, then you say it louder. Okay. I can put the minus, but I forgot to put the constant. Sorry about that. Let's back off here. Let's put a 2 in here. Yeah, this changes everything. I mean, all the rest of it. Okay? All right. But A is negative 1, so it'd be negative 8 minus 2b is equal to negative 3. Let's change all those negatives to positive, and you get 2b is equal to negative 5, so b is equal to negative 5 halves. And that certainly changes C then. Well, I should have left something there. Okay. All right, let's go back to our constant terms. That's 2a plus 4b minus 2c is equal to, has to equal 6. First thing I'm going to do is divide everything by 2. Okay, and that leaves us with, and a is negative 1, so I have a negative 1, b is minus 5 halves, 2 times that would be a minus 5, minus c is equal to 3, so add 6 to both sides, and you get minus c is equal to 9, so c is equal to minus 9. Yes, okay. Finally, so our complementary solution, our particular solution then would be minus x squared minus 5 halves, I can't write, 5 halves x minus, whoa, wrong. Okay. That'll be a 9. That's the 5 halves. Let me make that look better. Okay. Got it. Okay. I should have corrected that. So now we can write our general solution. Our general solution is a combination of the complementary solution and the particular solution. So y is equal to C1 e to the, they write it in slightly different form from this, but it's okay, minus 2 plus the square root of 6x plus C2, they actually put that as a C1 here, and they pull out the minus sign, e to the minus 2 plus square root of 6x, then your particular solution. And you don't do any constants with this. No arbitrary constants. Exactly what you've got here. And so not a minus, a plus, it's a minus. Okay? And that would be minus x squared minus 5 halves x minus 9. There is your general solution for that differential equation. Okay. Now, if you had initial conditions, how many would you need? You need 2 because you have two constants of arbitrary constants here. So you would need a y and you need a y prime, okay, for initial conditions. If you had those, you could solve for those. You don't ever mess with that, those stay there. They're the particular solution, they're part of your answer. Okay, so our y is equal to, and they wrote them different orders, they wrote the C1 e to the minus 2 plus root 6x plus C2 e to the minus 2 plus root 6x minus x squared minus 5x minus 9. All right, make sense? All right, let's then do the example 2. Find a particular solution for this. Y double prime minus y prime plus 2 is equal to 2 sine of 3x. Now they didn't say do the homogeneous, didn't say find the characteristic, the complementary solution. They just said do the particular solution. Okay? Now, they say here a natural first guess for a particular solution would be a sine 3x, right? Because this is 2 sine 3x, okay? But because when you take the first derivative of a sine, you're going to get a cosine. When you take the second derivative of a sine, you're going to go back to sines. But then you're going to have some combination of sines and cosines equal to a sine. And that's a little too restrictive. So since you're going to be introducing a cosine, your particular solution, y particular, will need to be not just a sine 3x, but also plus a b cosine 3x. Okay? That's your particular solution. What are we going to have to do with it? Always a good answer. Second? I can't hear. Yes, exactly. Y particular prime is going to be 3a cosine 3x minus 3b sine 3x. Perfect. And yes, yp double prime was going to be minus 9a sine 3x minus, second, 9b cosine 3x. Okay? Now you take that, put these values in to the left-hand side, and that would be minus 9a sine 3x minus 9b cosine 3x. That's the y double prime. Minus your y prime is going to be, I'll catch my signs here, 3a cosine 3x plus 3b sine 3x. You see that you had to change signs because the minus changes the sign of those two. And then, did I leave off a y? No, I wrote a 2 instead of a y. That's rather bizarre, okay? The old gray cells aren't working too well this morning, if you haven't noticed. I was telling Curry earlier, I was here until after 9:15 last night, so I'm sort of in la-la land, okay? So plus y, and your y was, y particular, is plus a sine 3x plus b cosine 3x, and supposedly this all is equal to 2 sine 3x. All right, so you tell me what we've got to do. Give me a, yeah. Anybody? For this second? Okay. Yeah, let's group our sines together and our cosines together. Okay? And if you do the sine 3x's, you see you get a coefficient of minus 9a minus 3, oops, wrong, 3b, okay, plus a, and that has to equal what the coefficient here is 2, okay? So that means minus 8a minus 3b is equal to 2. You buy that? Yeah or nay? Okay. Now let's look at the coefficients of the cosine. That would be a minus 9b minus 3a plus b is equal to what? Second? Okay, he's doing is combining minus 8b minus 3a, and what that's going to equal? What's your coefficient? Second? 0. That's equal to 0. So let me rearrange it ever so slightly to be a minus 3a minus 8b is equal to 0. Now there you have two equations, two unknowns. There's several ways you could approach that. What would be your way to solve that for A and B? You want to do a substitution? I should have known not to ask you. Never mind.
Like solve, make one equation, A is equal to the other side, and then plug it in the other one.
Okay, that's certainly doable. If I were going to do that, I think I would do this one and say 8b is equal to minus 3a, and then solve for b and plug that in there. Is that what you're saying? All right, that's one way. I kind of prefer to substitution elimination by addition, which again is sort of a pain in the neck. How would you do that? You also could do determinants, you could do Kramer's rule, you could do matrix. There's a ton of ways you can do this, but elimination by addition is usually not so awful bad. In fact, now that I look at it, maybe your method might work best after all, because it is pretty straightforward. So let's do it. You want to solve for A or B?
B, I guess.
Second? B, okay. And Monica's here. Only missing Lauren. I don't know. No, that's Lauren. I'm sorry. I just looked at you when you came in. I thought, okay. So we're not sure about Monica yet. So I'm going to put that. So Lauren's here. Okay, now before anyone leaves, I want to go over how the terms go in. I want to just say all that. Okay? So let's go back to Curry's method. You want to solve for A or B? I wasn't listening. B. Okay? So what we said here is that 8b is equal to minus 3a divided by 8, and you get b is equal to minus 3/8a. All right? Now, plugging that into the other equation, you get minus 8a minus 3 times minus 3/8a is equal to 2. Well, this would be minus 8a plus 9/8a is equal to 2, which would be minus 6 7/8. Let's make this minus 64/8. Okay, and then that will be minus 55. Minus 55/8a is equal to 2. Multiply everything by 8 and you get 16. Divide by minus 55 and you get 55. Okay, I think that a is equal to minus 16/55. Is that anywhere close to true? Doesn't seem like it is. I've done something terribly stupid, haven't I? Let's see. Again, the old gray cells aren't working well this morning. No, it's 73. Oh yeah, no, I think, well, I've done something wrong, but we're not too far off. It's the denominator I've messed up. Oh, it's a minus and a minus, I'm sorry, I blew that. It's okay. Let me start this over again. Minus 8a minus plus 9/8a is equal to 2. And that would be minus 64/8a plus 9/8a is equal to 2. And that would be minus 55. I'm making the same dumb mistake. A is equal to 2. So multiply both sides and you get, how did I get, I'm missing the 73. That's their denominator, mine's 55. I've done something terribly stupid here and I can't see what it is. Did I do the first part? And here's Monica. Good. I had marked you here, so I was psychic. Okay, so you are here. Perfect attendance, folks. Way to go. Last week of class, first perfect attendance. Let me go over how the term ends, and we'll come back to this. Maybe I'll have a fresh perspective. Okay? Now, today is last Monday of class. Tuesday of class. I don't even know what day it is. Thursday will be our last day of class. Okay? So, what I want to do first thing Thursday morning when y'all come in is hand out all your old tests to you. And let me go over this. Oh, wait. I've already returned test 1, haven't I? Did everyone get it back or is someone missing? Okay. That's right. I did return your test 1. Now, I can't return your research papers, those few that I have had, but you can see your scores as soon as I get them on Blackboard. Okay, test 2. Test 2. Test 2. I don't have any of those back, okay? Or if you turned it back recently, I don't have it graded. So please get those in. So I won't be able to turn those back to you unless you get them in before Thursday, and I have a chance to grade them before Thursday. But you have your test 1 back. I can't return your research papers, the one that has been turned in, maybe more than one, but one that I've graded, because we have to keep those for samples of student writing. But you can see your score anytime. You can look at the paper anytime, okay? And then I'll also be passing out to you at the end of class your final exam, okay? And that will be whatever we get covered in Chapter 4. We've already done 1 through, almost through with 4. We'll get as much as we can covered, and I'll give you a test. Now, since I have to make out the test before we have class, I may have too many questions on it. If I have too few, I'll just live with that. But if it's too many, in other words, something that we haven't covered, then I'll make those questions optional. Okay, so I'll give you that, when class ends on Thursday. Now, your research papers are also due in on Thursday. So please get me your test 2 between now and Thursday, and get me your research papers between now and Thursday. Okay? Now, I'll hand you out your last test, and that will be your final exam because it's the last exam, but it's not comprehensive. It's just your last test. And that will be due any time next week, Monday through Thursday. Okay. And let me give you my schedule for Monday through Thursday. Monday is really not due because Monday's still a class day. So I'm in here teaching from 8 in the morning, 8 to 10:40, and then I have a small 20-minute break, and then 11 to 1:40, and then I'm free for the rest of the afternoon. So the best time to bring it by, if you want to interact with me or whatever, bring it between 2 and 6 on Monday. Okay, you don't have to. That's before final exams are due. Tuesdays, no classes, just final exams. So you can bring it Tuesday anytime between 7:45 in the morning until 12 noon. At 12 noon, I'll be in my office. My office is down in 265. For those who may not know where that is, I pointed it out earlier, but let me point it out again. Here we are in this classroom up here, upper corner here. That's the classroom. You go out the door here, hang a left, go down this little half flight of stairs here, go almost to the end of the hall. The last office on the left is 265. There's a stairwell that's the last door on the left. There's a big mechanical room right next to, and I'm in between the mechanical room and the stairwell, right across from 256. The numbers here are rather bizarre. So you can bring it to me Tuesday. I'm there from 8 until 12. Around noon, at noon, I have a final in this classroom from approximately 12 to 2. It may not take that long. We'll see. I'm still waiting to see if we can go on a field trip on Thursday. If we do, we may have the last test plus the final for that class. If we don't have the field trip, then it'll just be the final. Okay? So I can't say how long that's going to take. So that'll be 12 to 2. I'll be up here approximately, maybe less. From 2 to 6, down in my office again. Okay? There for the rest of the day. All right? That's Tuesday. Wednesday, no classes, only finals. So I'll be down in my office from 7:45 in the morning until 6 in the evening, except when I have to go do something else, but I generally will be there. Thursday, wait, sorry, back off. On Tuesday, I missed something. On Tuesday, I'm back in my office after the final, that probably going in around 2, and I'll be in the office from 2 to 3:30, because at 3:30, I have to go to the Birmingham East Campus to collect finals for my evening class there. So I'll be in the Birmingham East Campus in Ethel Hall Health Professions Building, room 103, okay? And that's going to be from 4 to 6 on Tuesday, okay? Wednesday, I'll be here all day, 7:45 to 6 o'clock, down in my office or somewhere around my office. Then, Thursday is going to be a lot like Tuesday, only I've not got an exam. So I'll be in my office from 7:45 in the morning until 3:30. At 3:30, I go back to the Birmingham East Campus from 4 to 6. Okay. Now, they said that this summer, June and July, we're working 4-day work weeks. The college is closed on Fridays. I can't remember if they said anything about Friday, the 3rd of August. That's Friday of finals week. If they go by what they said, then we're open on Friday. But I think I heard someone say we would be closed on Friday still, and then open from Friday on. I just don't know. But it doesn't matter to me because I'm not going to be on campus Friday, period. I've got a treatment on Friday. I have to be there for lab work at 7. The treatment starts sometime around 8 or so. I'll be there all day. And then when I'm through with it, I'm not driving to campus because I shouldn't be driving anywhere, heading home, probably going to bed. Okay, so I will not be on campus at all on Friday. If the college is open on Friday, which I don't know if it's going to be or not, you can bring in work and slide it under my door, 265. Not the classroom door, please don't do it here. The office door, 265. But I'm not sure the college will be open. So that's why I say, please get me everything, your test, your last test, the final test, the papers, get me everything before by Thursday of next week. The second test and the research paper are due this coming Thursday, but if you don't get them in, get them to me before Thursday of the following week. Okay? Any questions on that? Grades are due. I have to have them in by noon on Monday. So if something has been slid under my door, say you came here Thursday, but it was after I left at 3:30, slide it under my door. When I get in Monday morning, I'll grade it and get it done. So anyway, if I'm not here, if you can't find me, slide it under my door. And I will grade. But I don't want to stack this big under my door Monday morning. Please get stuff to me before the last minute. Just like you've done your research papers, right? No, I just didn't say that, did I? Okay. All right. Any questions on how we're going to wrap things up? And by the way, if you start trying to see your grades on Student Suite Monday, you're not going to be able to get on Student Suite on Monday because they close down Student Suite so we can get the grades in. Because believe it or not, our old system is so antiquated, there are only so many portals, I guess is how you would say that, available, something like 16. And if all the students are trying to check their grades, we can't get into it to enter your grades. So please get everything in. Don't even look for it. If it's Monday that you're looking, look on Blackboard. And if I have your grades in, they're going to be on Blackboard first before they're on Student Suite anyway. So if they're not in Blackboard, that means I'm still working on them. Okay, let's go back to this. Has anyone seen where I made my mistake yet? So 8b is equal to minus 3a, b is equal to minus 3/8a. Okay, plugging that in. Here is the first equation, minus 8a minus 3 times a minus 3/8a.
It's plus 3b.
What's that?
It's plus 3b.
You're kidding me. Which equation? The first one?
Yep.
Okay. You're right there. Right. Okay. You're right. Right there is a plus 3b. Got it. Okay. So that's it. So b is equal to 3b. Yeah. Okay. So when that goes in, that's going to be a plus there, making a minus 9/8. So that makes a minus 73/8. No. Okay. Minus 73/8. It wasn't. Oh, okay, good. I was thinking of 75. Okay. 3/8 A is equal to 2. Okay. And then you get A is equal to minus 16/73, right? Got it. Okay. And then when you plug that into B, B is equal to minus 3/8 times negative 16/73. That's going to be a positive 6/73, right? Yes. Okay. Whew. Thank you. All right. Now, let's clear some space here so we can write down what our solution is. I think I'll take all this mess out because that was the problem in the first place. Okay. And we'll write our particular solution down here. Sorry about the math error, the transcription error. I wiped out probably more than I should have, but I don't think we need any of it anymore. Okay, so your particular solution is, that's all they asked for on this one. The y sub p is equal to, and they let off with the positive, so I think I will too, 6/73, and the b went with cosine 3x minus 16/73 times sine of 3x. There's your particular solution. Now, yeah, y sub p is 6/73 cosine 3x minus 16/73 sine 3x. Now, it says, as we mentioned, the form that we assume for the particular solution is an educated guess, but not a blind guess. So, okay, educated guess must be taken into consideration not only in the types of functions that make up g of x, but also, as we shall see in example 4, which is coming up after the next one, the function that make up the complementary solution, y sub c. Okay, so we'll have a couple of possibilities. So let's first do example 3. Everybody ready for that? All right. Let's solve this. Y double prime minus 2y prime minus 3y is equal to 4x minus 5 plus 6x e to the 2x. All right. Now, where do we begin?
What, are we doing all of it?
Yeah, but we're doing a bite at a time.
Auxiliary equations?
Say again? Yeah. And what do we put down? Okay, he's going straight for this, and where the m comes from, in case anyone has not caught on to it yet, the yc, no, this is complementary solution, is, and you probably shouldn't even put the c there, but this is for that part of it, is e to the mx. That's our first approach. I'm just going to put y, okay? and that's where the m comes from. So that gives you m squared. Continue. Minus 2m minus 3 equals 0. Because this is the complementary part that you get from the homogeneous form. You set this equal to 0 first. Later we'll worry about this with the particular solution. We start with this, and this will give us a complementary. So what do we do next? Okay, we factor this as m minus 3 times m plus 1. Okay, just a quick check and make sure that works. It does. Equals 0. What does that tell you? Either m is equal to 3 or m is equal to negative 1. What do we do with those? That'll be c1 e to the 3x. Remember, we're plugging these m's back in here, okay, plus c2 e to the minus x. Okay. Now, complementary solution done. No initial conditions or anything else, so we don't have anything else we can do with those c's. Now we focus on the particular solution. Does anyone want to hazard a guess of what your particular solution might be? Okay? Here's a little hint. Let's break this into two possible deals. Let's call them G1 and G2. What would be your y particular for the first one? Y particular 1, let's call it. AX plus B. That sounds like a good choice. Now, here's where it gets a little stickier. We haven't dealt with anything with products yet, so let's see, what are we going to do for this? Y, let's call it P2. What might that be? Second, C, X, e to the 2x. Is that what you were thinking? Okay. Not a bad guess. Okay. What's that? Or e to the what? No, you're going to have e to the 2x there. Just remember, like we had sine 3x before, we didn't change that. The coefficient can be changed, but not the other. Now, the only thing that's different, let's see, difference here is, and you have to sort of go back in your mind a little bit and remember when you solve forms that look like this. That was with when you had multiplicity here, or you remember when you were doing your things here, if this had come out at m equal 3 and m equal 3, you had two of them, then you might have to do your solution might be e to the 3x plus x e to the 3x. So that's the form that's going to get you something that looks like this. So you actually do need another term, and that other term is just with the e to the 2x plus d e to the 2x. Now here's the other reason for that. Just like we did in sines and cosine, even though our g of x before was just a sine, we had to include cosines because once you do a derivative of a cosine, a derivative of a sine, you introduce a cosine. And so you're going to have to deal with cosines. When you do a derivative of this, sure, you're going to get 2cx e to the 2x, but you're also going to get a c e to the 2x. So you're going to need a term here that doesn't have the x in it. So either way you want to look at it, you need that term. Does that make sense? Because when you do a derivative here, which you got to do, you're going to wind up with a term with no x in it. And since you're going to have terms with no x's, let's go on and put them in there to begin with. Okay. Now, what we're going to do is, say, our particular solution, yp, is going to be a sum of those two. So that's going to be ax plus b plus cx e to the 2x plus d e to the 2x. And now we go to town with that one. What's the next thing we do? Help me, help me. What do we do next? Take a derivative. Y sub p prime is equal to a plus, product rule, c e to the 2x, is that what you said? Okay, plus 2c x e to the 2x, is that what I heard? Okay, plus 2d e to the 2x, right? Everybody agree? Okay. Now, all right, second. Okay, yeah, but I'm trying to decide if I ought to combine like terms first. I sort of feel like I should. It's going to be a plus c plus 2d e to the 2x plus 2cx e to the 2x. I think that's going to make life a little easier shortly, okay? Like when we take the second derivative. So y sub p double prime is then going to be what? Two c plus, did you say 4d? E to the 2x, okay, plus okay, say that again. 2c e to the 2x, that's right, plus 4c e to the 2x. Wait, x. Yeah, okay. Left off the x there. Okay. Now again, we can combine a little bit here, and this will be 2c plus 2c would be 4c plus 4d e to the 2x plus 4cx e to the 2x. So, seems like we ought to factor out a 4 there, and maybe we should. Okay. All right. Now let's put all that together, and your y double prime, I'm going to factor out a 4. I hope I don't regret it. Okay. Times c plus d e to the 2x plus cx e. I'm thinking I want to factor out e to the 2x too. I might regret this, so live with me if I do. Okay. It'd be 4e to the 2x. Take that out too. That gives me a c plus d plus cx. Right? Minus 2 and your y prime. There'll be a minus 2a minus 2c minus 4d. I think I'm just going to do, I'm going to just do a minus 2 in front. Okay. C plus 2D I'm really going to get myself confused here, I'm afraid, but I'm going to do it anyway, okay? Because this is just getting too much to carry on. Okay, I'm going to factor out the 2 minus 2, okay? Okay, and now I'm going to put my y prime in here, a plus c plus 2d e to the 2x plus 2c e to the 2x. I don't think that's helpful, but we'll see. Okay, and then minus 3 times your y particular, and that's that. So it's minus 3ax minus 3b minus 3cx e to the 2x minus 3d e to the 2x. I've just mixed everything up here. And like I said, I probably will regret it. Let's see. I'm going to need some room. So I think I will, hopefully don't need this anymore, so I'm going to start up here. I think I need to leave my particulars here. I won't need that one, but I do need the others. Okay. So let's see what we got. Now supposedly all that's equal to 4x minus 5 plus 6x e to the 2x. All right. Now, let's try to find our x terms. And I think the only x term I see is this one right here. Minus 3ax minus 3a then has the equal to 4. If I'm seeing it right, that's the case. So a is equal to minus 4/3. They sure like negatives here, don't they? Okay? Okay. That one's good. Now, let's deal with the constant terms. This one has no constant terms, but this one does. So here we have a minus 2a minus 3b. That has to equal negative 5. Do you buy that? Okay. So I'm going to make all those positives because I don't like hanging around with negatives that much. But the a is minus 4/3, so this is going to be a minus 8/3 here, plus 3b is equal to 5. So let's make that 9/3 and 15/3. Okay? Add an 8/3 to 15/3, you get 23/3. So we have, let's just go back to b here. 3b is equal to 23/3, and divide by 3, and that makes a 9 down there. Okay, so b is equal to 23/9. Good deal. Okay? All right. That's our constant terms. Okay? Let's go to the e to the 2x terms. Okay? And this will be 4C plus 4D minus 2C minus 4D plus 4C. Did I leave off the X on this one? No, I don't think I did. This is driving me nuts. Yes, I did leave off the X on that one, so that's not there. Okay. Okay. All right. Okay. I think that's all of them that are e to the 2x's, and there aren't any e to the 2x's there, so these have to equal 0. So we have 4c plus 4d. Well, let's see. The plus 4d and minus 4d, I think we lose them. So that leaves us just 2c is equal to 0, which means c is equal to 0. Which I doubt if that's the case. Yes, I've messed something up. And it's all this mangling around I did with this. 4c plus 4d minus 2a, no, minus 2c plus 4, minus 4d, okay. I think I left off a term, is what I did. Minus 3y, I did leave off a term. It's a minus 3d e to the 2x. Sorry about this. This is just not doing well today. Okay. So let's go back up here. And we have a minus 3d. That's equal to 0. Okay, those two go away. That leaves us with 2c minus 3d is equal to 0. Okay. Now, we can't do anything with that yet, but 2c minus 3d is equal to 0. Where did they get an e here? Oh, what I'm calling d, they're calling e. And I think there's a reason for that, but I'm not sure it's a very good reason. The capital D stands for the differential operator. So they're avoiding the D. Sorry about that. But we're not confusing this with that. So 2c minus 3d is equal to 0. We have that one. Now let's do our last one, which is the x e to the x terms. Okay? And this is 4c from here minus 4c from there minus 3c from that one. Oh, sorry about this. I hadn't left off that term. I'd written it down below, so it was there all along. I just missed seeing it. Okay, sorry about that. And this is equal to 6. Okay, well, there's no d's in that. find that kind of hard to believe. Oh, no, there aren't any. So this gives you minus 3c is equal to 6, which means c is equal to negative 2. And since that's true, that'll be negative 4 minus 3d is equal to 0. So 3d is equal to negative 4. D is equal to negative 4/3. Okay, they call it E. Okay. Now, with all that in mind, I need to erase some stuff. And I think I'll start erasing here, because I don't want to erase any of that I really need. Okay. I must have already erased some of that. Okay. Okay. I really probably should have erased that ugly line at the bottom too. I think I will. That was really made some poor choices there. But it all worked out. I hope I don't need any of this. If so, I'll just have you reproduce it. The rest is left to the student. Okay? So what is our particular solution? Yp is equal to A. I know I've got it here. There it is. Minus 4/3 x b 23/9 plus 23/9 plus or minus c is a 2, or plus c is a minus 2, x e to the 2x minus 4/3 e to the 2x. There's your particular solution. Okay? Minus 4/3 x plus 23/9 minus 2x e to the 2x minus 4/3 e to the 2x. Okay, now we have our, don't tell me I erased my complementary solution. Did I?
It was C1, e to the 3x.
I'm sorry, yeah. So here's what our general solution is. Y is equal to C1, and say again? E to the 2x plus C2 e to the minus x, right? Minus 4/3 x plus 23/9 minus, was it a 2? Yeah, 2x e to the 2x minus 4/3 e to the 2x. All right. Now, Houston, we may have a problem here. Why? Because we have the e to the 2x here with a c, and there we have one with a minus 4/3.
It's supposed to be 3x.
What's that?
The first one's supposed to be 3x.
Oh, it's a 3x. Okay, why'd you let me write it wrong? Okay, that now we have no problem there. Okay, that's a 3x here. See, I erased that and I don't have it anymore. So 3x. All right, now we don't have the problem. Okay. Yeah. Okay, they put their C1s and C2s backwards from us. The rest of it's fine. And they also combine these two terms, factoring out e to the 2x. So theirs looks a little different. C1 e to the 3x plus C2 e to the minus x minus 4/3 x plus 23/9 minus 2x plus 4/3 times e to the 2x. I think that's how, yeah, that's how they wrote it, which is fine. It's perfectly okay. What kind of makes it a little more appealing is that this is a linear form like this, and this has that characteristic in it, but it just has the e to the 2x in it. It's just the way it looks. There's nothing else that's anything all that special about it. Okay. Now, they have a little blurb at the bottom is, in light of the superposition principle way back in 4.1.7, you could also approach example 3 from the viewpoint of two simpler problems, and you can go back and look at that as well. All right. I'm about ready for a bladder break. Would y'all like a quick break? Because I think we've been at it an hour and 45 minutes or so.
Yeah, we have 10 now.
Huh?
We only have 9 minutes left.
Oh, wait a minute. I'm sorry. We've been at it a lot longer than I thought. Yeah, we don't need one. Well, we might need one, but we can live without it. Okay, let's do 4. Okay. I'm sorry. I thought it. I guess I made so many mistakes it made time fly. Okay. Here's a glitch in the method is what they call it. Find a particular solution of y double prime minus 5y prime plus 4y is equal to 8e to the x. I was sort of looking ahead to this one without realizing it. This is where our situation is going to do. If that was our problem, and we just looked at the particular solution, what would you guess it would be? Yp would be ae to the x. So yp prime would be ae to the x, and yp double prime would be ae to the x. So what we would have here is ae to the x minus 5ae to the x plus 4ae to the x, okay? And that adds up to 0 is equal to ae to the x. Oh, that sounds like a fine particular solution, doesn't it? Okay? 0 can't equal ae to the x because ae to the x is always positive, so it can't be 0, ever. Okay? Now, where did the glitch come?
It's not going to be linearly independent.
What's that?
It's not going to be linearly independent.
Okay? Yeah, let's go back to our,
It'll be negative x.
let's do the complementary solution. What would that have been? A complementary, no, auxiliary equation. M squared minus 5m plus 4 is equal to 0, right? M minus 4 times m minus 1 equals 0. So what would your m's equal to 4 or m's equal to 1? And what do you notice here? Your complementary solution, y sub c, would be c1 e to the 4x plus c2 e to the x. Uh-oh. If this is a solution to the homogeneous form, then no wonder this is gives you 0, because that is the same. This is the same here. You just put a rather than c2, and because of the way we set it up, that has to equal 0. So, surprise, surprise. That's why they didn't have you do this first. because you might not have recognized that. They just say go to a particular solution. So that particular solution doesn't work because it's one of these forms. All right, so how do we remedy that? And is that what you were suggesting? What were you saying?
I said what, they weren't linearly independent.
Okay, yeah, but what do we do to solve that? What did we do before when we had multiples rather than a to the e to the x? We throw in another x. So this time, since this is e to the x is one of your complementary solutions, then you can't use that as a particular solution, but you could use a x e to the x. And guess what? Don't even mess with the b e to the x, because you know what that's going to turn out to, 0. Okay? So that's where we begin here. Okay? So let me change this. So that's why you always do the complementary solution first, to make sure that your particular solution isn't replicating a complement. Oh, I hit the wrong button again. Okay, so this is going to be a x e to the x. Okay, so what's your yp prime now? Got it. And your yp double prime? Okay, which will be 2a e to the x plus a x e to the x, right? All right. Now, these we plug in here. Going to take a little more room to do, but I think we can handle it. Y double prime is 2a e to the x plus a x e to the x minus 5a e to the x minus 5a x e to the x plus 4a x e to the x, and supposedly this is equal to 8 e to the x. Okay? Where do you go from here? What's that? Yeah. Yeah, let me pause just a second and make sure we, yeah, okay. Actually, that's not a bad idea, okay? Just to get them out of the way so you don't have to worry with them anymore. Okay, you have to do both sides though. And what does that leave you with? 2a, second. Okay, yeah, let's combine those without x's first. Minus 5a yeah, that's it, right? Those are the only two without x's in them. That's got to equal to 8, right? Okay, so that's going to be minus 3a is equal to 8. So a is equal to minus 8/3. They just love having these negative coefficients, don't they? Okay, now the rest is just a check. Let's see if that makes sense if we plug in that value with the x's. Okay, so we have a minus, that's from this one, minus 5a plus 4a. Yeah, guess what? That adds to 0, doesn't it? So we don't have to worry about it. So here's our a. So now we plug back in. So our y particular solution is minus 8/3 x e to the x. So our general solution y is equal to c1 e to the 4x plus c2 e to the x minus 8/3 x e to the x. And if you wanted to, you could rewrite that as c1 e to the 4x plus c2 minus 8/3 x e to the x. Okay, I think that's probably how they write it. Well, I don't know if they write it. Oh, they didn't even ask for that. They just asked for the other. Are we out of time? Okay. Let me give you a few homework problems first. Where we're going to start next time is, I guess we're just going to do case 1. Okay, we'll start case 1, bottom of page 146. Okay, this is a long section. Homework exercises, any of the odds 1 through 25, any of the odds 27 through 35, 37 or 39 or both. No, wait. You know, we probably haven't done all those yet. Just do some of 1 through 25. If some of them are a bit beyond what you feel like we've done, we'll come back and cover those after we cover the rest of them. All right, good deal. We'll see you. Perfect attendance today. Keep it up for the rest of the term, right? All right, good deal. Yeah, I'm through. Good deal, thank you.